Okay, let's get started. Hopefully you all had a good break. I had the break of catching up on things that I wasn't able to get to before the break. So hopefully that was good for me. Hopefully you had a relaxing break. So I have one real announcement. So apparently you did see the announcement. I didn't get a copy of it, so I didn't know. So I'm going to be speaking at the C++ Now conference in May about my experiences in teaching modern versions of C++ to beginners, namely you guys. So if you have any suggestions about what I'm doing right, what I'm doing wrong, especially what I'm doing wrong, um, what concepts you liked or didn't like, anything of that nature, it would be really appreciated if you can send those to me. And if you want, I can put your name in a list of people I give special thanks to for acknowledgement. So if you have any suggestions, just email me or tell me or whatever. So that's that. Another thing that will be posted pretty soon, hopefully, is assignment 6. So I'm just going to briefly go over this, but basically what you're going to be doing is writing a solver for a game. So there's this game, Alpha Bear. Has anyone played this game, Alpha Bear? If you haven't, you should. It's really, really fun and really, really cute. So what's the objective here? So I'm not going to go through the document, but this picture will be enough. So you have this grid of letters with numbers. So you notice that the higher the number is, the darker the color is. So 9 has like a darker green. The 4s have a lighter green. The 3 has a yellow. If you did 2, that would be orange. 1 is red. So what that indicates is the number of turns you have left. And so if you have a letter with a turn of 1 and you don't use that letter, that's a bad thing for the game. You don't get as many points. So what you want here is you have all these letters with these numbers on this grid, but you want to prefer the ones that have a lower number so that you can capture that letter and use as many points as you can. So what you're going to be doing is you're going to be looking through a long list of English words that we'll provide to you. And then what you'll be calculating is some metric on how good is this word on this grid? How good is this word on this grid? And then you'll find what is the best word should I pick at this moment. And that's it. So it's actually really cool that you can use these concepts to solve a game pretty simply. And then there's a lot of stuff here which you'll get to read hopefully pretty soon. So we'll post that pretty soon. Are there any questions about anything? What's due on Wednesday? Assignment 5. Any questions? So hopefully that should be a pretty interesting assignment. Yeah.
So what's like the threshold that you want to find size?
As small as you can. So if there is something obvious that you should have done, like say that you turn in your source code and there's still comments in there, you could have done that. But if there's like something that is really advanced that you didn't think of, we won't worry about that sort of thing. It's just, did you actually try to make the file smaller? What were some of the techniques that you did? So it's not necessarily a threshold that you want, that we want. It's that did you try to use all the techniques that you know? Did you try to use functions? Did you try to use references? Did you change this to be this? Did you shorten the variable names? Did you get rid of comments? That sort of thing. So it's like, did you actually give it a fair shot at trying to minimize it? And then as well as, or did you actually try to minimize the executable that's formed? Or were you not able to do that were there some things that no matter what you tried, the executable didn't change size. It's your ideas that are important. It's not the actual file size that's important. But it's just showing that there are a lot of techniques that you can try, and so being able to try those is what we're looking for. Other questions? Okay. So what have we been talking about? We've been talking about these things called objects. So very briefly, what's an object? Just generally. Yeah, we define it. So what things are inside an object? Or what could we do to an object? So what things go inside an object? Functions and data. Yeah, just generally. It has data and functions. So we put data inside this object, and then we define some function on that object that may or may not change the values inside of the object. So we've been talking about this for a little bit. So we came up with an example. The one in the slides I have is square. The one that we have been talking about is circle. So in our circle class, we had two variables which define what the circle is. So we can specify a radius and we can specify a color as a string. So then we talked about like what types of functions would we want. We may want to know the area of the circle. So do we need to store the radius and the area simultaneously as two variables? Or do I only need one? We only need one because from one of them you can figure out the other one. But it makes sense that we usually specify circles by radii, so radius is a good choice here. But I could equally do area. And then we have a function called getArea because we still want to know what the area is, but we only need the radius to do that. So let's just manipulate the radius by calculating pi roughly times the radius squared, and that gives us the area. So let's make a function that will do the computation for us instead of storing the value ourselves. Then we talked about setters and getters. So getters just get the value out from the object, and setters take in a value and set the internal variable accordingly. So why do we have setters and getters instead of just making the variables public? Because I could just equally make them public and avoid this setter-getter nonsense. Well, we can. So this is limiting access to the variable, of course, but if I have a setter and getter for radius, I can just call these functions and just act like I'm manipulating the thing publicly. So what advantage do we have here? And it's kind of right here. With a setter as a function, I can actually do extra stuff inside of the function. If I just made the variable public, then I can't do any other validation to see if I'm trying to set it to a bad value. Whereas if I have the setter, if I have a setter function, I can do a validation stuff in here because it's a function. I can put any amount of code in there I want versus just making it public. So that's why we have setters and getters. We talked about the first two access specifiers. There are three, but we're going to do two for now. Public, everyone sees the whatever it is that's public, and private is only the things inside the class can see it. So it's private to the class. Public means anything can access it. So in this example, the side variable is private, so only the things inside the class can access side. And we have the setter and getter both public, so anywhere, if you have a square object, I can call set side or get side from anywhere. So yeah, I use the dot operator for this. So dot operator says, at this object, SQ1, I'm going to call the setSide function on the SQ1 variable, not the SQ2 variable. So when I do the dot lookup like this, I'm looking it up on the particular object. I'm not looking it up on any other possible object. So when I call setSide here, SQ2 is left alone because it has an independent copy of the functions and variables. When I call sq1.getSide, it accesses the getSide function of the sq1 variable, not the sq2 variable. Yeah, so we talked about getters and setters. That's what that slide has. Inline functions, this isn't really that important, but inline functions are just ones that are inside the class. And sometimes you want functions outside the class, and we'll get to reasons why you want to do that later. But if you want it outside the class or after or whatever, you just say the class name : the corresponding function. So nothing really interesting there. But sometimes you want the function inside the class, particularly if it's short. It makes sense to put it in the class. But if you have a long function, you may want to put it outside the class because it's easier to read that way. Some conventions. Variables are usually private. The functions are usually public. Sometimes there's one goes the other way, but that's what the convention is. Yeah. So there's some trade-offs here. Yeah, so when you call a function, the control passes to the function. So an inline function can make for a larger program, but is sometimes faster because there's not as much time or resources needed to go over to the function and then return from it. Whereas a regular function can make the program smaller, but you need to jump to the function and then jump back. So there are some trade-offs here. It's not a big deal anymore, but it used to be a big deal. Then we talked about constructors, which are what? So what's a constructor do? Default argument, but so generally, what does a constructor do? Construct or? Yeah, it builds the object. So what it does is it does any work that's needed to set up the object fully so that everything is all set. So like for the square class, the only thing that needs to be set up is the side variable. So what you do here is you set up the side variable. You give it the value that was passed in. But you don't need to do anything else. So that's the only thing that goes in that constructor. But of course, you can have multiple constructors. So the default one is usually when you have no parameters at all. So you just make the default version of the class. So an analogy of this is if you have a blueprint for a house, the default constructor for the house is you don't do anything else to the house. You just follow exactly what the blueprint says, and you don't add anything else extra. So you do exactly what the blueprint says. Whereas for any other constructor, you need to do something special for the house, or in this case, a square. So that's what a default constructor is. And here's an example. So no parameters passed in. So maybe the default value of side is 1. So it depends on the class that we're dealing with, but 1 is a good example here. So if you want to call a particular constructor, if you just make a square object like this, then this will call the default constructor. Note, there can only be one default constructor. Because if there are two, there will be a compile error, so it wouldn't even let you. So this will call the default constructor. This one will call the constructor that takes one integer as a parameter. So this one, this 8 here, will call the constructor with one argument, not the default one. So sometimes you want to call the default one. Sometimes you want to do something special by calling a different constructor. Okay, so I think we ended here. So let's continue from here. So a destructor is basically the opposite of a constructor. A constructor sets up the object, a destructor destroys the object, right? So what happens when you call the main function as an example? So when you call the main function, if you have like an integer or double or whatever, it sets up the memory, the amount of memory that's needed so that you can hold that object. So, or the integer, double, or a square, or anything really. You set up the amount of memory that's needed, and then when the main function goes away or the program stops, that amount of memory is freed back. So it's no longer in use by the program. And so why would you want to do that? So why would you want to have the program free up the memory that it uses when it's done? Right, so that something else, some other program in your system can use that memory. So think about like if you're using Chrome, for instance. So there's a lot of memes about how Chrome uses a ton of memory, like 1 or 2 tabs causes the entire system to crash or something. So when you quit the Chrome application, then all of that, you notice that your computer sometimes gets a little faster. The reason for that is that all of the memory that was used by the Chrome app is now freed back to the operating system so that other applications can actually use it. So a destructor here is basically if you make a mess, the destructor cleans it up for you. So if you want to make a destructor, what you do is you put a little tilde in front of the class name and then make a function as normal. So we did an example of this last time where we were talking about the circle class, and here, right here, is the destructor. So there can only be one destructor of a class. But here I have a destructor, and here I'm printing destroying. So what you do in a destructor is you free up any memory that you're using. So if you're using some memory of some kind, you free it up in the destructor. What the interesting thing is here, well, notice that I have a double radius right here in a string color. But in the circle destructor right here, I'm not freeing up that memory. I'm not freeing up the radius or the color memory. So what do you think is happening here? It's actually very, very cool. So what happens here is if all of the objects in your circle class have their own destructor, the circle's destructor will call those destructors. So when circle destructor is called, when it's about to exit right here, so it's done, the circle destructor's done, it calls the radius destructor, and then it calls the color destructor. So that all of this freeing up is transferred to the other objects, and then they handle their own data, which is really cool. So if you have an object in here which has a defined destructor, then you don't have to worry about it. In fact, I don't even need to make a destructor here because everything that I'm using right here, these two objects, have their own destructor. So I don't have to do anything special. When we get to pointers and arrays, we will need to worry about that sort of thing because they don't have a defined destructor. But everything that we've done so far has a destructor. So the cool thing is that as far as we need to know right now, you don't have to write a destructor of any kind, which is nice. But if you wanted to define one and maybe do something special in it, this is how you do it. Tilde, class name. There's no return type. Do constructors have a return type? Not destructors, constructors. Do they have a return type? Well, one way to find out. Let's look at the code here. Does this have a return type, this constructor right here? No. So constructors don't have a return type. Destructors don't have a return type either for similar reasons. It always takes no arguments. So destructors don't take arguments. And one destructor allowed per class because it has no arguments. And the great thing is that if you really did need to define a destructor here, let's just say we had to do one, you don't have to call it yourself. So what do I mean by that? So notice, I don't have to, in the main function right here, right before it does the curly brace at the end, I don't need to call the destructor right here. I think that's how you do it. But you don't need to call the destructor yourself. When the object goes out of scope, so like C goes out of scope at this last curly brace right here, it automatically calls the destructor for you. So you don't have to worry about it, which is really cool. There are some cases that we haven't gotten to yet, but we will when we get to pointers, where you do need to do something special. And there's a special keyword that you do there. But here you don't have to worry about any of that. Any questions about just what a destructor is? So it destroys the object, essentially. Okay. So a lot of this stuff after this we kind of already covered, or is really basic, so I'm just going to go a little faster through the rest of this. Private function can only be called by other functions of the same class. It's private to the class. It's used for internal processing, obviously. So now, what's interesting here is that if we have a function, we can actually pass other objects to that function. So, yeah. So, note, what are the two ways that we can pass data? By value and by reference. So, can anyone tell me what by value does, just at a high level? Right, it makes a copy, and by reference, what does it do? It uses the same location, right? Same idea here. So if I pass an object to a function, so like I'm passing a circle to a function, if I do it by value, it makes a copy. If I do it by reference, it references the original. Same as before, there's no difference here. Yeah, so when passed by reference, you can use the set functions to modify the object. So if you do it by reference, you're still modifying the original object. So if you call .set radius or whatever, then you're modifying the radius of the original object. So it's exactly the same as before, but now we're working with objects. Nothing new here. Yeah, so what you usually do for objects is, so note, could objects have as much memory or as many variables as they want? Yeah. So if I am not smart and I just say, I'm going to pass it by value, could that be a problematic thing? Right. That could be problematic because if they use a lot of memory, then we're going to go back to the Chrome thing that we had earlier. We're going to use a lot of memory. But a lot of the time we don't want to modify the object that was passed in. So usually we put reference because we don't want to make a copy, but we don't want to modify it either accidentally, so we say const. So it's const ref here, the const reference to a square object. Yeah, so that's what you usually do. So this last bullet point is something that so this is straight from the publisher. This is not my slide. So I just want you to I want to warn you about just trusting what other people say without checking it yourself. So look at what this says, even though it's bad English. In order for the show data function to call the member functions, those functions must use const in the prototype and header. So you may notice here, well, does this really tell you anything? What do you think this const means right here? If you do know, don't say. If you don't know, what do you think this does? Well, let's see. So I'm passing in a const reference to a square object. So I can't modify it, and it's referencing the original. So could I, let's just say I have a set side function of square. Could I call the set side function here in the show data function? Could I call set side? No, why? Right, it's a const whatever square, right? So I can't modify it. Should I be able to call get side? Yeah, so if the get side function doesn't do anything to the square object, so nothing changes, should I be able to call it? Yeah, it makes sense. In here, since I'm not allowed to modify it, but I still want to do something with the square object, I should be able to call a function that is guaranteed to not modify anything. So the set side function does modify stuff because it's a setter, but a getter usually doesn't modify stuff on the inside. So this const on the end, so only on the end, means nothing is modified in this function. So nothing inside the class, it changes in this function. Whatever happens, nothing changes. So let's actually look at an example of this. So let's just say I tried to put const on the end here for set radius. I need to put it up here too, because it has to match. But let's just say I wanted to compile this. I should have CD'd in. So let's just say I wanted to do this. Nope, it's called circle herder. Okay, so let's actually look at this. So it says that you cannot assign to ignore what non-static means. But essentially what that means is you have a normal data member. So in this case, it's radius. There's a normal piece of data in there. You can't assign to it within a const member function, which is called set radius. So here, I can't modify I can't call set radius to be const because something is assigned to in the function. So I should get rid of these, but I could call get radius to be const because is there anything being assigned to in this function? No, there's nothing assigned in this function. But the interesting thing is, I could put anything I want in here as long as I'm not modifying some internal variable of the circle class. So as long as I'm not modifying stuff, I'm okay. It'll turn out that this doesn't work, but let's see. It does work. So I was kidding there. So here, as long as you don't modify stuff in a const function, that's great. Why would you want to do this? Other than the example that we had in the slides where you could modify it, not modify it, you could call this function there. Why else might this be a good idea to put const here, saying that nothing is modified?
Ease of understanding the program?
It could be ease of understanding of the program. But one thing that is really troublesome is when you do multi-threaded programming. So you have, like if you have multiple cores on your machine, and let's just say that they're trying to all modify the same object. So they're all trying to modify the same circle object, for example. Maybe you're trying to do a game or something where you have two players, and you have all your cores trying to modify the enemy or your player or whatever. Maybe try to look up their position. Well, if you have a function which is guaranteed to not change anything on the inside, then what happens is if all of these cores call this function, then the state of the object is consistent. Nothing changes. But if all of them call a non-const function, then it may be that one core gets one version of the object, and then another core gets a completely different version because something was changed halfway through. So when you have const functions like this, it works very well with multi-threaded programming. We're not going to get to that in this class, sadly, but there's a lot of reasons why you should put const on functions wherever you can. So if nothing changes inside the function, put const on the end. Any questions on that? Okay. You can return objects from a function, so instead of just passing it to an object, you could return it. So look at this example here. So maybe what you want is, so instead of declaring an object in like the main function, what you do is what is called a factory method. So a factory method is you have this factory and it's just shoveling out objects for you. So what you just say is, I'm going to call the factory and I'm going to order 10,000 of these square objects, for example. So what this factory function is it does all of the work in setting up the object, maybe do other work, maybe do some inputting like this example, whatever that's needed, just do all the work there and give me the objects at the end. So what I do in the main function is just say, I'm going to make a square object and I'm going to call the init square function. It's going to give me the square object immediately. And so I don't have to worry about making a square object myself and then set it up and then work with it afterward. I just call this function and it gives me the square object immediately. I won't go into that. Yes, but the issue is, what if you wanted to do some inputting like this example? So like if you wanted to set the side of the square to be a certain number, then you need to do the inputting as well. Or maybe you want to call various functions like that do certain operations on the object, but you can't do them in the constructor, or you shouldn't do them in the constructor. So it's nice to put a bunch of work that's not just put into the constructor all in one function like this. But you're right. If I do have all this work and I only need the stuff in the constructor, then doing this is useless. So that I just make the square object immediately and I don't worry about anything else. But if I do have to do something else, then a factory method like this would be a much better option. Another reason might be that maybe you want to make a whole bunch of squares and then return them all in some superstructure of some kind. We haven't talked about what that is, but maybe we want to make a whole bunch of them. Instead of calling square S1, square S2, square S3 inside the main function and clutter up the main function, we just offload it off to a function. Any questions on returning objects? Okay, I won't talk about that yet. So there's this thing called composition. So there are various ways of having multiple types of different objects work together. So look back at our example of the circle. So what objects are inside this circle? The double radius and the color. So what composition is it's an object of objects. Okay? So the idea here is that we're going to have some objects that are going to be put together to build a larger object. So in this case, we have two objects. Okay, doubles are not really objects, but let's just say they are. So we have these two objects, and we're going to make a circle object that uses both of them. That's composition. So whenever an object is a variable of a different one, that process is composition. So it's basically what we've been doing so far. If you have an object inside a class, let's just say double is an object, then that is called composition. Yeah, so here's just an example. So if you have a rectangle class, then it makes sense that if you're trying to make carpets, for example, I don't really know many carpets that aren't rectangles, but it makes sense to have a carpet class. Let's just say that they all are rectangles. To have a rectangle inside of the carpet class. Because if I want to know aspects of the carpet, then what I can do is the rectangle defines the length and the width of it for me. I don't need to, in the rectangle class, in the carpet class, I don't need to specify the length and the width myself. The rectangle handles that for me. So I don't have to worry about that sort of thing. So, so what I can do here is, suppose that I wanted to make a get color function of the circle. Well, I don't need to worry about, like, how am I going to store the name of the circle? Am I going to have some characters or what? The string color right here, it handles the naming for me. So I don't have to worry about it. So if I wanted to have a get get color function, then all I need to do is return the internal variable color. I don't need to worry about the structure in which the name is held. So what I could do is I can just offload the work to one of the objects that I'm holding and let it do the work for me instead of having to do it myself. So if I wanted to have a class that is devoted to a pair of circles, so maybe I want to check that one circle is a player and one of them is an enemy, and then maybe I want to know, are they colliding or something? I'm trying to make a game. Well, in the pair of circles class, should I have 2 radii and 2 names? 2 colors, or should I have 2 circles? 2 circles sounds a little bit better because I don't have to manage the radii and the colors anymore myself. The internal variables of the colors, of the circles, they handle the work for me. So you may be wondering, how do we actually do that? So let's actually do that. So let's make a class pair of circles, no parenthesis, and a semicolon at the end. So what you do here is, in the private section, I'm going to make 2 circles. So and then in the public section, we can do whatever. So I'm not going to fill it in here. But notice, instead of having to manage the radii myself and the colors myself, I can just call the various setters and getters of these circle objects right here and let them do the work for me in managing the radii for me. So I don't have to worry about that anymore. I only have to do the work in the getter and the setter exactly once. So I only have to do the setter and getter of radius and color inside the circle class. I don't have to do that in the pair of circles class. Yeah.
So in the pair of circle class, the class circle that you call it, like that just calls that class.
Yeah. So the question is, are these just the objects of the circle class up here? And yes, they are. So I can compose objects upon objects upon objects upon objects and make this as complex as I need it to. So what I could do, say for ASU, is I can have a class called person, and then, or student or whatever, and then I can say a course like this is going to be composed of multiple person objects. So instead of having to manage the name, the ID, and everything else about a person inside the course class, I have the person class do that for me, and then I just hold the person objects myself inside of the course class. So I can have objects be used as objects inside of a different class. Okay, any questions on what composition is? So you're just composing objects together. Okay, so this is more of a convention than, and it's a really strong convention, than an actual requirement. But I'm going to have you write, if you're going to be writing classes from now on, I highly recommend you do this. So what is here? So the convention is we have these classes that we define and some functions which are outside of the class. Usually the ones that are longer, but any number of them could be outside the class. What you do here is you put the class itself, not the out-of-line stuff. You put the class itself in what is called the header file. Okay? So header is when you have a .h file. Sometimes you see .hpp, meaning header for C++, but the name of it isn't really that important. As long as you have a file that is for the class itself. It's called the header file. So in this case, if we wanted to make a square header file, I'd say square.h. The name is not important. In other languages it is, but here it's not important. If you want, so now we have the header, but we want to put the out-of-line stuff in a different file. That's called the implementation file. So you have a header file over here and an implementation file over here. What happens, and that's usually called .cpp. Again, the name is not important, but it's a good idea to do this. So we have the header over here and the implementation in a completely different file over here. So because they're in separate files, we need some linkage between them. So what you do is the CPP file over here, the implementation file, includes the header file. So it only includes over here. And then if we want to use the header or the CPP file, say in the main file, then we include only the header file. We don't have to include the CPP file. So instead of hand waving it, let's actually do it. So let's open the directory. Can I make it bigger? No, I can't. So what I'm going to do here is I'm going to make, go into Sublime here, and I'm going to make a new file, and I'm going to call it circle.h. So because it's .h, should I put the class in here or the out-of-line stuff in here? The class part. So let's put the class part in here. So everything from the class, if I can scroll. So I'm going to cut all of the stuff from the class and just paste it in here. Nothing new. Nothing really too hard here. So notice, is this function right here, set radius, is it outside of the class?
Yes.
Yes. So what file does that go into? Yeah, so I need to make a circle.cpp file. So that goes in here. What else do I need to do to link the H and CPP file together?
Pound.
Yeah, pound include. So in the CPP file, we include the header file. Now, when we included stuff before, how did we do it? So if I wanted to include IOStream, we had the angle brackets. So I've neglected to talk about this for a while, but now you're finally old enough, I can actually talk about it too. So when C++ files love each other very much, no, I'm kidding. So when you have an angle bracket file like IOStream or whatever, that is a system header file. So it belongs to the system. But do these circle files like .h or whatever, do they belong to the system? No. So what you do instead is quotes. So double quote the name of the file. So double quote circle.h, like this. But otherwise it's exactly the same. So you hashtag include the name of the file, but now we put it in quotes. For the main file, so actually I'm going to rename this. So usually you call the main file main.cpp. So So if I tried to compile this, what do you think would happen? This file as is. It would be an error because it's saying, oh, you're trying to look up this circle object. So I'm trying to look for the circle class. I don't see anything in the IOStream header, and that's all you included. So if we try to compile this, it should give us an error, which is like, I don't know what this circle thing is. So what you do here is the exact same thing you did in the CPP file. You include with quotes, the header file. And you don't have to include the CPP file. Cross my fingers if this works. Nope, it does not. Oh, okay. So I know what happened there. So let's actually look at this error. So it's saying from main CPP, in the circle.h class, it says unknown type string. What do you think is happening there? So let's look. Oops.
There's no standard namespace.
Yeah, but that's not the only thing. So let's put our using namespace std thing, which would partially solve it, I think. Oh. Oh, okay, I know what happened. It's something that we'll get to in one of the future slides. But this works. So then if I run.a.out, it does the calculation that we have done before the break. So the cool thing is that you only have to include the header file, and now my main file is shorter. So it's kind of like modular programming, where you have, instead of this huge file, we break it up into multiple pieces, and then it's a lot easier to work with. So now if I wanted to work with circle.h or circle.cpp, then I just only need to look up that file instead of having to search through one gigantic file. So now what I recommend is if you have multiple classes, you put each class in its own header and CPP file so that everything is nice and tidy. So you don't have everything in one file. You could do it all in one file, but it's not convention and it's not as easy to use. Any questions on doing that? Yeah. Oh, good point. I forgot to mention that. So here, if you're going to be making your own header and CPP files, they have to be in the same folder. There are some tricks that if you have different files in different locations, you could get around that. But for this class, all you need to do is put them in the same folder. Okay? Any other questions? Okay, so this is what I wanted to get to. So notice when I did the using namespace std thing that it worked. What I anticipated to be the case is that in the header file, I needed to include something that allowed us to use a string because there's no include as is. So if I do IOStream or just straight up include string like this, then only then would it be okay. What happens here is something called an include guard. So what happens is, suppose that we have multiple classes in different places, and I include our circle class over here, and over here, and over here. Then what may happen is that some problems may arise. So if you have some header file included twice, then there are problems that might happen. So an include guard says, if you've included it before, I'm not going to include it again. So what's really cool is here, notice that we've talked about this before. In the IOStream header, it includes string itself. So if you actually looked up in the IOStream header, there's an include guard for string, but there is an include guard there. So I don't actually need to include string here anymore because it's already included from IOStream. So because it's already included, I don't need to do this include for the header file right here. So that's why it actually worked. There's a reason why we needed to put this here, but I won't go into that. But the point is here, an include guard says, if you're trying to include twice, I'll only include it once, and then just use the one that you've already included again if you try to include it again. So it just prevents it from include it twice. So how do you actually do it? We'll talk about next time.